Hi, everybody. Hey, thank you for joining me for this first episode of a new Freem Builders stream. So I'm Aaron Bassett. I am developer relations at Parity Technologies, where I do a lot of work with Freem and Substrate in general. Still pretty new to it myself. I'm a recent graduate from the Polkadot Blockchain Academy. So we're still going to be doing a little bit of like learning in public here on the stream, but it's mostly to be like just focused on live coding. We'll build out a Freedom project and just kind of see where it takes us, to be honest. So this is, as I said, brand new. First time we're going to be doing this. It's one of our first live coding streams that we're going to have on the Polkadot channel. And to be honest, I kind of want it to be really interactive. So hopefully we've got some folks in the chat. I know we have people joining us from some on Twitch, some on YouTube, a few on LinkedIn. And I'll be keeping an eye on all of the different chats. So if there's anything you want to talk about or like anything you want me to go over or explain better, or something that you don't quite understand, or I've explained really badly, or something you're like, hey, that's the wrong way to do this. Like, what are you doing? Like, this is a much better way. So we're all going to be learning a little bit in public here as well. Then please do let me know in chat. I have it open right over here. So if you see me looking this way, that means I'm looking at the chat. So please do get involved, ask questions. Just let me know what kind of direction you want this to go in. So for this first one, I thought we would take a look, go right to the beginning, basically. Let's pull up my screen here so y'all can see what I'm talking about. Okay, so we have, let's load this one in. This thing called the Substrate node template. If anybody's seen any of my, I've done a couple of workshops recently as well. I'm not sure people have kind of seen those, like a consensus and things. If you have, then you'll be very familiar with the Substrate node template. For those of you who are not, I always have to do this because this tripped me up the first time. Is the Substrate node template is a blockchain node. Okay, not node as in Node.js. It's not JavaScript. It is a blockchain node. Okay, so the whole thing's written in Rust, no JavaScript at all, and it can be confusing because we have the Substrate node template. We also have in here the Substrate front end template, which does use Node. So the node template doesn't use Node, and the non-node template does use Node. Everybody got that? Awesome. Okay, cool. But yeah, going back to the Substrate node template. So this is like a really great starting point if you want to write a custom palette. It's got like a runtime and stuff configured in there for you. It's got like a template palette as well, just to get you started. And that's really where we're not going to be. Hey, good morning, Phil on tour. Good to see you. Thanks for joining us. Yeah, and it is morning here. It's like 9 a.m. So I'm feeling very alert for this time in the morning, if I'm being honest. It's like I used to do a lot of live coding, like a lot of live coding streams and things. This is my first time really doing it at Parity Polkadot. And I have to admit, my biggest concern at the moment is accidentally showing something on screen I shouldn't. So I used to work at like a telecommunications API company. Think like Twilio. It wasn't Twilio, but think like Twilio. And it was kind of a rite of passage there that at some point, you'd be doing some live coding on Twitch or whatever else, or like a webinar or something. At some point you would accidentally show your cell phone number, because you'd be like sending test messages to like a number or something like that. And if you hadn't got a burner phone, which people tended to do after the first time they showed their personal number on screen, if you hadn't got a burner phone, then you'd be like using your own phone for testing, and eventually you would show the number on screen. Or worse, you would show your API keys. And for that, it wasn't that big of a deal, like it's live, it's out there, there's nothing you can do about it. But you would just like hop on the company Slack, go to support and be like, hey, can you quickly rotate this key for me? Like that was really all it took, not a big deal. Somebody could send a couple of text messages from your account, not a huge thing. Now I'm like, oh, I'm going to be live streaming, working with like Web3 and Polkadot and stuff. And like, okay, yeah, I have obviously my hardware wallet, but I'm like, I actually like, what if I accidentally show my seed phrase, So there's a little bit of anxiety going on in my life coding this, I have to admit. But we're not going to get into any of that kind of stuff today. But it does kind of wake you up a little bit in the morning to kind of think about those things. But yeah, back to the substrate node template. So this is like a great starting point if you want to, give a try about writing your own kind of frame palette. It has everything you need in here to like run a local node. It's got like a runtime and stuff pre-configured for you for it. Hey, thanks for the love. Yeah, it's got like a runtime everything configured for you. So I'm not really we'll make a few modifications to that today. Probably not an awful lot, to be honest, just enough to get it up and running. But the main thing we're going to look at is this like template here. So we got in this palettes folder, there is a template, and this is like your frame palette template. And in it's got like, some of the kind of boilerplate that we might use. So I've actually already created this is actually a template if anyone wants to use it. So I've created a new repository out of it already. It's a public repository. So like if y'all want to, I'll just put this in chat here. This is where I'm going to be using this repository throughout like all of the live streams. So if, at any point today, next week, I should probably say as well, this is going to be a weekly stream as much as possible. We're going to be doing it every Thursday, 9 a.m. East Coast times. It's like, I think, is it like 3 p.m. Central European? Am I getting that right now? I think so. But yeah, we're going to be this time every Thursday going forward, as long as conferences and things permit. So yeah, we're going to try and make it weekly, at least weekly going forward. And anything that I'm like coding and stuff, it's going to be in this repository. So I'll push up at the end of each stream. People can go take a look and stuff. Yes, let's go, Peter. Eastern time zone for the win. Yeah, it's a bit early for the people on the Western time zone right now. I'm sorry about that. Hopefully you can catch the recording later. Okay, so we have our copy of this. I've already pulled it down because it's just a full blockchain node and it's Rust and it takes a little bit of time to compile it. So I wanted to compile it first. And this is how we do this compilation. Oh, you can't see it because my camera's in the way. Let's move me over here. Hey, oh, no, it's really tiny. Oh, okay. We can fix this. Let's put me somewhere else. Where am I going to go? Let's put me up here. Better? We're going to go bunk. Hopefully that works. Nothing like editing your like streaming software on the fly, folks. But yeah, okay. So hopefully now you can see that I've got this like cargo run -- release. So that's going to like build my blockchain node. The -- dev part of it is quite important here. That flag is going to run my node in dev mode, for local development. And what that means is it's not going to persist the database. So every time I stop this node and restart it again, it's going to be like I'm starting from Genesis every time. Okay. The other thing it's going to do is going to create 2 accounts. You probably, if you've worked with Polkadot at all, good. I'm glad that worked for everybody. You can see now you can't see it because I'm putting your messages on top of it. Okay. I'm sorry. I'll hide you again so you can see the commands. But yeah, if you've worked in like Polkadot and stuff before, you probably heard like Alice and Bob, and that's 2 test accounts it's going to create. So we'll have like a couple of accounts with some tokens so we can like run some tests and things with them. So yeah, we have our cargo run release. I'm going to run this. It's going to go build my node. I've already built it once this morning. So it's like all ready to go. It didn't need to really compile anything. And that's it. We've got like a running blockchain on my local machine, which honestly, I think like that's pretty amazing. Like, okay, I sped it up a little bit because I already compiled it this morning. I'll make some changes to it in a minute and you can see how long it takes to compile, like once you made some changes. But even with that taken into account, like this is a freaking blockchain on my machine, like running right now. If I had other machines on the same network also running this, they could peer together. Like this is a real blockchain. In fact, let's go look at Poo.js. Okay, so I'm going to assume I'm not going to make that assumption at all. Like for anybody who's not familiar with Polkadot.js, it's a development tool to allow you to kind of interact and explore blockchain. So not just like your local one, you can do it for any substrate-based chain. As far as I'm aware, like here's Polkadot. So let's switch to Polkadot. We can see. Okay, we are at block 15,576,270. And we can see every time a new block's issued, we can see the events that are going on in that block. There was like a transfer of like 162 dot from this account to this account. We can see all these different events that are happening in each of the different blocks. We can go into a block. So let's go look at that one. We can see here is a list of like all the extrinsics that were called and okay, crypto crew. I have to figure out how to block people on this. Thanks for that. Anyways, I'll let somebody else figure out how to do the YouTube stuff for me. But yeah. Hey, Mohammed, greetings as well to you. Good to see you. Joys of live streaming and having an open chat while working in this industry, folks. Please ignore any of those messages on YouTube. Sorry about that. Anyway, where was I got? Yeah, okay. So Polkadot.js, you can explore kind of like any of the networks. So we have like all the Polkadot ones. You get Kusama. We have the different like test networks. So we've got West End, Rococo, etc. But you also look at like your local development ones. And somebody's asked me about, don't I worry about last day's unbonding of mine? That's not what I'm on this here to talk about, to be honest. Like that, I'm just here to talk about kind of frame, coding, etc. I really don't have an opinion on that to share. So it's not something really we need to discuss. Anyway, okay. So we can also look at our local development network. Make sure I've got it running here. Yeah. Oh, it's trying to look at this block. And we don't have that block. Okay, because we only got 32 blocks. We don't have like 15 million blocks, whatever it was. So this is my local node that's running. You can see here, this is like the blocks that are being created. And I should point out as well, like a lot of people talk about the UX and UI for, let's move me back down to the bottom while we're talking about this, just because like you can see the top here. Everybody talks about kind of like the UX and UI of working with Polkadot and how it's like, not consumer friendly or easy to use. And what they're talking about normally when they say that is this, they're talking about Polkadot.js. And honestly, that annoys me so much because Polkadot.js is not a wallet. Can it be used as a wallet? Sure. Yeah, of course you can. It is a developer tool. And it's a pretty awesome developer tool. Like, not gonna lie, I use it a lot. Sure, it probably could have a few different tweaks to it, but the amount of control and the amount of functionality it gives you as a developer is awesome. But yeah, it's not the most user-friendly wallet because it's not a wallet. Like you want a wallet, go use like Talisman or Nova or Subwallet, any of those kind of ones. They're actually wallets. If you want a developer tool to interact with a substrate-based blockchain, then use Polkadot.js. Like it's as simple as that. So yeah, whenever I'm like at a conference and somebody complains to me, is like, oh yeah, I tried staking or I tried like this and your wallet UI. And it's like, okay, what did you use? What did you use? Was it Polkadot.js? Because that's not a wallet. That's my rant over. So I have this node running, but let's go look at like what it does. So I said we have this pallets, we have template, and we got the source directory, and then here's this librs. And whenever I don't know if you're familiar with Rust at all, and you're probably familiar with this pattern of like having a source directory and having a librs directory. This means this is a library file. And this is where most of your pallet code is going to live. Now, there's a couple other files in here. We've got like a benchmarking file. We have oh gosh, again, I am just like in the worst possible place for people to be able to see what's going on. Let's move me back up here again. Yeah, so you have like a librs file, you have like test file, you have a benchmarking file, you've got weights files, but most of the code is going to live in this librs. Okay. And that's one we'll be working in majority of the time whenever we are looking at building our own pallet. And the librs file is going to have like a bunch of different stuff in it around. Well, let's go for it in kind of order. So the first thing you see, we're like defining this module of pallet. We have a bunch of macros to help around this kind of stuff. We're not going to go into like what each of the macros does right now. There is a deep dive. Staking dashboard too. Yes, staking dashboard is awesome. I should have called that out explicitly. Staking dashboard. It's what I use. And yeah, it is so nice. If you haven't looked at staking in Polkadot in a while, go check out the staking dashboard. The work they've been doing there is phenomenal. Yeah, it's even if you're happy with the way you stake at the moment, just go check it out just for the UI. But yeah, so the we have a palette, like we have a bunch of macros to kind of take away some of the boilerplate for you. I'm not going to go through what each of the macros does today. There is on the YouTube channel one of the deep dives. I think it was, or no, sorry, one of the Substrate seminars. But before Lauren took them over, Sammy and Sasha went through like macros, like Substrate macros. It's a really good episode. Go check it out. The recording off that stream is on YouTube. And yeah, it goes into so much detail about the macros and what they do. I'm not going to touch upon it here because I would not do Sammy any justice. He did such a good job with it and understands them so much better than me. I'm just going to brush over the top of them and be like, hey. Yeah, we're just going to brush over the top of them and I'll leave it to the people who write that stuff to actually explain it. Okay, so we also have in here, so we got like a config. We can see, here's our runtime event that we're setting up because we're going to be emitting events from this, like we saw in Polkadot.js, like different events get emitted. You can see them. We got some storages as well. Storages is like one of my favorite topics in Substrate. I could talk about storages for hours. We probably will at some point, let's be honest. But for now, we're just going to be like, look at this really briefly. This is creating a storage called something. And it is a storage value. So it's like, this is going to think of this as like a variable that holds a single value. Okay. So we have this variable something. It's going to hold a value. This underscore thing here, the first argument to storage value is always going to be the prefix. Okay, so prefix is how you find that storage value. And the prefix by default is made up of the pallet name and the storage name. Okay, underscore just means use a default, and that's what you're going to use like 90% of the time. But as I said, the default is made up of the pallet name and the storage name. So if for whatever reason at some point in the future you need to change the name of your pallet or you need to change the name of this storage value, then it's, you're not going to be able to locate it anymore. Okay, it's going to have a different prefix than what it currently has now. So if you do need to refactor those, rename them, and you don't want it to be a breaking change, like you do still want to be able to look up the values for that storage item, then you need to set the prefix yourself. But as most of the time, you're just going to leave it as underscore, accept the default value. So the other thing we have here then is the type of value we're going to store. The something is just storing a U32. And then we get into the events. These are the different events that we can emit. That was the things we saw, like, let's go look at Polkadot.js again. So if I go like back to Polkadot, let's switch back to it. And we can see, we'll let a couple blocks go and we should start to track some events in here. And these are events that are being emitted, like, whenever a block is authored. So these are all events. Okay. So like a balance transfer is an event, nomination pull paid out is an event, staking bond is an event, etc., etc., etc. Okay, So lots of different events, and you can write and you can create your own events for your own pallets that can be emitted as well. And these are really handy because you can watch them in the dashboard. There's different tools that you can get to like listen for particular events if you're interested in, so on and so forth. It's also a good kind of way of like reporting success. It doesn't have to be success. It's what it's commonly used for, but it can be just like anything you think should be reported back. So let's have a look and see what else we got. Okay, so in this event, then we have just a single event of something stored. It's going to take two variables, the something, which is going to be a U32, and who, which is going to be an account ID. Okay, so that's like a substrate account ID. Then we have our errors, similar to events. These get emitted as well when something goes wrong. Okay, and we're going to talk about like the difference between returning an error and panicking. You never want your chain to panic. That's bad. But you can return an error. Like an error doesn't need to be like an actual error in your extrinsic. It could be that somebody's done something wrong. So an error could be, oh, I want to transfer X amount to X to Y and I don't have enough, or I'm trying to perform an action and some other prerequisite has not been met, those kind of things. So the error doesn't need to be, oh, something has gone wrong with your code, or like it can just be these preconditions have not been met. So errors in here, we have a non-value and a storage overflow. So we'll see how those are like returned later on. Where it gets really interesting is when we get into this call section, which are our extrinsics. So the extrinsics are the things that we can actually call on our blockchain. So in this instance, we have two. We have a do something, and that do something takes our value that we want to store, and it puts it into the storage. Okay, we'll go through this like a bit better in a second, but that's general gist of it. And then we have this cause error, which, as it sounds like, tries to read a value from storage. If there's no value, then it's going to like raise this error. And if there is a value, then it is going to try and add 1 to it. And if it can, great, it'll put that in storage. If it can't, then it's going to overflow. So if our new U32, if our U32 is at the max size already, and then we try to add 1 to it, it's going to overflow. Okay, so we want to catch that. So that's why we just like check that here. And then we want to return an error instead. Again, we'll go through these like in more depth in a second. But that's the basic extrinsics. And then if we go back to our Polkadot.js, we can see under developer tools here, because this is a developer tool. It's not a wallet, developer tool. If we go back to our developer tools, we can see under extrinsics that we have our template module. So that's this thing that we're looking at, template. Okay. And it has 2 extrinsics we can call. Here's our test account, by the way. This is Bob. This is Alice. Hi, Alice. Hi, Bob. And under a template module, we have this do something and we have this cause error. So I'm going to call the cause error first with nothing saved. Boom. Immediate non-value raised, which the name should change to Polkadot dev.js. Yes and no. I can, because Polkadot.js, it could be used, it's like any other kind of library. It can be used to build lots of things. I'm pretty sure we probably use it in like the staking dashboard and things like that as well. It's just that Polkadot.js itself like has this apps section, and so it is like it's a framework for helping you build client-side applications or JavaScript applications using to interact with substrate-based nodes. And one of the things they have here is this apps wallet, which is a wallet built on Polkadot.js stack. And that's what I'm using here. Don't get me wrong, it is awesome. Like I use this every day, like without fail. I probably spend as much time in this application as like nearly any other. Okay. So I am not slating this in any way, but it is a developer tool. Like in my mind, that is what this is. It's not a user facing wallet. Okay. And it kind of has, that first mover advantage. I think it was one of the very, very early ones. And that's what people like tried. And then like, oh, this is not very user friendly. And it's like, yeah, because it's not designed to be. But yeah, it's awesome. Probably doesn't need to change the name to that, but I can see the thinking behind it. It's the beefiest Explorer wallet hybrid you'll ever see. 100%. It is so, so good. Okay, so back to our extrinsics. We have like our template module. We've run our cause error. We saw like it's gonna get a little red thing over here in a second. Wait for a new block. Boom. Okay, non-value, which is what we expected. Yep, non-value. Okay, perfect. Exactly what we expect. So now if we call our do something, and let's give it, value 10, we submit that transaction, sign and submit, wait for a block to be offered, bang. Okay, so we've got this like do something, extrinsic success, balance withdrawn. So you can see a bunch of stuff actually happened here that I didn't need to explicitly like call out. I can see here is my event, my something stored event, but like let's look at this. I see a lot of other things were called, in order to do that. Okay. And the reason I had to like, why did it withdraw from my balance? I'm not doing there's nothing here that's like going, oh, transfer some token or any of that kind of stuff. Like why is it doing a balances withdrawal? It's because there's fees involved. Okay. Like computation is not free. Like validating transactions is not free. Offering blocks is not free. Block space itself is not free. So in order to compensate people for that, then, you pay a fee. And I think we can see like on these, let's go, let's see. Does it tell me what it's going to be ahead of time? Let's store 20 this time. Okay, here we go. So there's my fees is like up at top. Let's sign and submit. So that's going to take that fee, etc., etc. How it works out that fee is based on this line. Okay. I'm not going to get into this today. There is a couple of deep dives on our YouTube channel that go into kind of go into benchmarking and things. And that's how you work out what the fees should be that's paid, is you use just a bunch of tooling and Substrate to allow you to work out the computation, how difficult the computation or how long computation or how much storage any particular extrinsic is going to take. And then you can calculate your fees from that. You never really want to be returning like a weight of 0, because then that's going to be, an extrinsic you can call for free. And that opens you up for denial of services. Somebody can just keep calling a function, regardless of whether that function does a lot or does a little. If you can call it for free, then you can call it as many times as you want, and you're going to start causing degradations in service. Okay. So this is where weights come in, is it's like, okay, how computationally expensive or how much storage is needed to execute this function. That's going to, help decide how much of a fee that you pay. So that's why whenever I do these, even though this is the actually only event I'm emitting or extrinsic that's being called, we can see there's like a lot of other stuff going on. So here's something stored that was called, but here's like where I withdrew the balance. Here's where the fee was paid, etc., etc. Okay, so there's a lot of other stuff goes on, not just this one call. Now, what is the U32 max in Rust? Should we try and generate that other error? No. Doesn't matter. Let's not bother with that. I could figure it out. Like, I think there actually is a U32 : max _ size in Rust that will tell you what it is. But trust me, if I try to add one to it, it's going to overflow. Right. So let's try and make some changes to this template. What I'm thinking I'm going to build in this series is a logistics palette. So logistics is something that's like a pretty common use case for blockchain. If anybody's not familiar with the term logistics, it's moving things from one place to another. Okay, so think of like any of your courier kind of companies. Somebody gives them a package, they accept that package, they create a QR code or whatever for it, saying, okay, we have this package and we accepted it at this location, and now we're going to send it to whatever destination. Okay, and through that journey, it may hit like multiple other places. Each of those places, then it's recorded who accepted it, so who's now taking responsibility for the package, where was it accepted at. Okay, it should be, what time was it accepted, etc., etc. We want to have some kind of record of where your package has been. If anybody's like lost the package or been sitting like refreshing, waiting for something to be delivered, you having up-to-date record of where your package is, who has it, what the next step is, etc., etc., is obviously very important. Having something that can't be changed as well as immutable, very important too. So you can't have somebody go back in and like, accept the package, loses the package, and is like, I'm just gonna say I never got that package. Okay, we don't want something along those kind of lines. So it's a really common use case for kind of blockchains in general. And we can build that all in a pallet. That'll have different extrinsics, ones for somebody creating a new delivery, accepting the delivery, etc., etc. So we're probably going to build that out over the next couple of weeks, but we can get started on it today. And the first thing we're going to do is I'm going to rename this template palette into your logistics palette. Now, I don't need to rename it. I could just like cd into our, what directory are we in, into pallets, in here, and like, okay, so a template, I could do like a cargo new, because like if we look at this in here, like it is just a regular crate. Okay, we call them pallets. That's part of like our terminology for them in Substrate. So you get Substrate and you have frame, and frame is composed of pallets. That's just our terminology for it. But a pallet is a Rust crate. Okay, so you can create a new pallet just by going in here and doing cargo new and giving it a name, and that'll create a new crate, which is a pallet. But not going to do that, because instead what I'm going to do is just rename this template one. And the reason I'm going to do that is so that we can see all the different places within this within the Substrate node template, like in our runtime and like all our different configuration files, where we need to change or where we would need to add in our new palette. Okay, so let's just do like a little search in here. That's the right search, is it? I want to do a find in files. Yeah, that one. And we're just going to search for template. There should be a bunch of them come up. Let's kind of zoom this in here so you can see a bit better. Okay, cool. So we have a lot of different stuff comes up here. So we got this cargo lock file. Which cargo lock file is that? I wish it would show me. Oh, here we go. Okay, so this is in. So we never want to edit any cargo locks. Okay, we don't remember edit those directly. So I can just close this. But we have our cargo toml. This is in our main directory, and we can see it's got this like pallets template. So let's go take a look at that. Okay, so yeah, we have pallets template. So that's first thing that's going to go. We're going to change this to logistics. So this file is in. Let's go back to the directory so you can see it's right here. Okay, so that's like at our top level. We need to change this now that members of our workspace is going to include like our node, our runtime, and this palette we've just written. Okay, so that's one place where you need to add in a new palette to use it in your runtime. Let's go look at some others that are going on here. We're not going to worry about the README. README is going to say template a bunch because like it's the Substrate node template. A standalone version of the template, template repository. It's going to be in the README a lot. So we're not going to worry about changing those. We will update that README at some point, for other people following the stream, so they know what what's going on, where they can watch the stream, when it airs. We'll put all that in the README at some point, not today though. So I'm just gonna close that one out. We have our dev container.json. This is for like setting up our like container stuff for it. We're not going to worry about that. Again, it's talking about like the actual template itself, not our thing. What's this one? We got a config.yaml. This is for issues on GitHub. We don't care about that right now, so we're going to get rid of it. We have our Rust setup MD, which is in our docs. We don't care about that right now. We're going to get rid of it. We got another cargo.toml file. Which one is this? This is our node cargo toml. So in here, in our node, we have a cargo toml. This template it's referring to here is the node template itself, not the pallet template. So we can safely ignore that. Okay, so there's no updates required in there, as far as I'm aware, as far as I remember. So we can close that one out. Benchmarking. Okay, again, this is the benchmarking for our node. I don't think we need to update anything in here. We can close that. Chain spec. Again, no. Command RS, no. Mean RS in our node, nope. So you can see like most of the things in the node here, I don't really need to update. We can skip those. There's nothing to be added in any of these or in this. Okay, here we're now at our cargo.toml file for the pallet itself. Okay, and it's so yeah, this is going to do some updating. So this is the cargo.toml file in our actual palette. Okay, so this one. So it's going to be, now we're going to change this from template to, this is going to be logistics. We'll keep the same version number. No, we won't. That's silly. Let's make it. It's our very, very, very first version. And this is a free palette. Is going to be an example frame palette for the frame Buidlers live stream. Cool. We'll leave this stuff all the same. This is going to be the same. This is the same. We're not going to publish it. I probably should change this repository to my repository, which is this one. Let's kind of make it smaller just so I can see a little more what's going on. Okay, thank you. Okay, so we're going to change that. Now here we have all of our dependencies and a lot of stuff going on in here. You know, we've got ones for our benchmarking support system. That's all fine. Substrate core, IO runtime, all fine. Nothing else to update in this, I don't think. We've got all the template stuff. Okay, cool. We'll save that. Let's go look where else we need to update. Benchmarking. Okay, so in our palette, we also have our benchmarks. We're not going to look at, well, go away. We're not going to look at what this does right now. That's going to be like in a later stream, but we'll still update it. Just don't forget. So we're going to use create palette as logistics. What else we got going on? So here's our do something that we had here. You know, so we can see this is how it's calculating our benchmarks. Again, go look at watch the YouTube video about like the benchmarks deep dive. It'll tell you. It'll make so much more sense. And here we're gonna change this to logistics. Cool. I think that's all we need to do in this one. Yeah, let's just save that. What else we got going on? Mocks. Okay, cool. Let's load this up. So mocks are used for like our tests and stuff. So we're getting like a mock runtime that we've got here and things. We'll look at this in more depth in a later stream when we get to like doing testing. But for now, we're gonna just change this to pallet logistics. What else we got going on here? Test. So this is template module. We're gonna change this to logistics module. That's gonna be pallet logistics. What else we got on? Any other templates going on in here? Do we see any? Palette template needs to become palette logistics. Go. Yeah, I think we covered it all. Let's see that. Tests. Okay, we'll change the test. We're not going to use them just yet again, but this needs to change then from template module to logistics module. Same for this one. Anything else going on in here? Yep, there's one more. We'll see that. Okay, widths. So the widths file, let's go open that up. Auto-generated. Okay, so we're not going to touch this because this is all generated for us. So I'm just going to leave that as it is for now. It's cargo to Tom. Which one is this? This is the cargo to Tom for our runtime. Okay, so we may need to make some updates in here. So let's just have a look through this. I know it's going to say template a lot because it's like part of the node template runtime, but there might be other stuff that we need to update. So here's like all its dependencies. There's a lot of dependencies. You know, things are balances. We got like stuff here for consensus. Pseudo, which is awesome. We'll talk about pseudo. Let's actually talk about pseudo now. Why not? Like, let's do something because I'm kind of getting bored of just like doing a find replace. Pseudo comes in around here. So in this instance, I have like this ensure signed. Ensure signed means that whenever can I still run this? if I let's do a cargo check to see if I've just broken my pallet. 100% broke my pallet. Okay, we'll fix my pallet in a second. I'll show you what I mean. I see. I can. Yeah. Okay. We'll fix it. I'll show you. But essentially, if you saw me like using Polka.js a moment ago, whenever I was submitting a transaction, I would have to like submit it as signed, and that's what this is doing. You know, so this is this origin is like the caller. You know, who is submitting who is calling that extrinsic, and this ensure signed ensures that caller that submitted a signed transaction. So I've like signed that transaction. It can only be me that is submitting it, et cetera, et cetera. And this is what you're going to use like 90% of the time. You know, it's very rare they're going to allow somebody to submit a transaction and not have it signed, you know, not be able to. Anyways, seems you very rarely have one that didn't have a weight, you know. So signed transactions are what you're going to use like 99.9% of the time. But what you can also do is there is like an ensure root. An ensure root is ensuring that the caller is actually like the runtime itself. So that's using this pseudo palette, and that's for things like, you know, you might want to do for your runtime upgrades, etc. You know, you don't want that just being like regularly callable. It's probably going to be called like via pseudo, yada yada. Okay, we'll look at it in more depth later on, but pseudo is like really handy for certain things. Pseudo timestamps. We have like all of our like core consensus, runtime, etc. Benchmarking. Oh, here we go. Okay, palette template. So I need to become palette logistics. What did we make our version? It was like, I think, yeah. And we're gonna rename this directory as well in a second. So let's just change that. Palette logistics. Anything else? I think it's gonna be something here. Okay, yep. So palette logistics. You ever type a word so many times you're just like, that cannot be how it's spelled. Just starts to lose all meaning. Logistics. And logistics. Okay, cool. All right, so we've got like our runtime, benchmarks, and our standards library, and our dependencies all updated in our runtime. Awesome. Save that. Those ones. librs runtime. Okay. So this is our runtime, which is this thing here that's being configured for us to run our local node. Now, runtimes, like if we let's go look at like Polkadot itself. So let's polka dot. No, not in Repo. We're gonna search for polka dot. Polka dot. Okay, so even polka dot itself has like this runtime directory, and here we have like a bunch of the different runtimes. So we have polka dot. Makes sense. We have Kasama, like the Canary Network. We have like Rococo and West End and everything else. And we go look in Polkadot, Source, librs, and this is going to look really similar, you know? So like it's just using the same stuff. This is just like configured for you to run your own local node. Okay. But it is essentially exactly the same as what you would do for like running your own relay chain or anything. It's just another runtime. So where do we need to make changes to this? Let's see if we can find anywhere that it is importing template. Let's look at our search. Import the logistics palette. Let's update our comments as well. Why not? Also, I know I can just do like there's some easier ways of doing this, like finding and replacing stuff. I'm doing it manually, just so you can see the different places where if you do want to add your own pallets to this, you need to go in and like update. Okay. So like things in your runtime, things in like cargo.tomls, benchmarks, weights, tests, etc. Like there's a lot of different places you would need to either add in your new module, or if you're renaming the template one, go through and make changes too. Okay. So that's why I'm doing this the hard way, if you like. So we got our create runtime, node template. Nope, that's not our template. That's talking about the node template. Again, configure the pallet logistics in pallet logistics. Pallet logistics. And down here as well. All right, so we got a bunch of those. Compute the custom logic from the pallet logistics. We're going to call this logistics module. Logistics. Okay, what other ones we got? Benchmarks. Okay, so now we're just changing this as well. Logistics module. Okay, so it's only two we got left, and they're talking about the actual node template itself, so that's fine. I can go. Okay, I think we've updated everything apart from the actual name of the directory. So we're going to get move pallets. Hey, thank you for the autocomplete. Whoop. Oh, up a directory. Okay, cargo check. Make sure, hopefully I haven't missed anything. And this also shows you like what the build times are more like when you're actually working on this kind of stuff. Is it does take a minute. Okay, so there's like our check is run, so that's good. Let's do our build our release. We'll see this will take a second. And actually, sometimes I should pre-warn you as well. It can eat up so much processing power on my machine that my webcam stops working or like flutters. So if like I'm on stream and suddenly webcam goes black, I'm probably building the node. Just putting that out there. Hopefully it doesn't happen this time. But yeah, as you can see, it does take a little minute for it to work. Which yes, if you're used to faster kind of turn times, you're web application developer like I was for many, many years. I was used to like hitting Command S in my editor and having it do live reloads. So I would like Command S, go to my browser and see the changes immediately. Not quite the same here. Whenever we're building a release, it does take a little bit longer. The awesome thing though is like with Rust and with like the Rust analyzer, it can catch so many minor problems that it's like the only language where I can write 300 lines of code and run it and it just works. Like whenever I was writing Python, I could write maybe 3 lines of code, run it and it might work. 300, probably not. That's why I was saving and checking my work like so constantly. With this, yeah, I don't need to build a node quite so often. You know, I'll sometimes I'll write, you know, 2 or 3 or 4 extrinsics and then go back and see if build my node, go check them out. Okay, so there we go. So it's built. And if we go look at our Polka.js now, let's refresh this because it's gonna like be, I can't find that block. Here we go. So we got Explorer. As I was saying, because I'm building this with dev, like it's resetting every time, like we talked about. Okay. For anybody who's like new joining the stream, this flag here, dev, means that I'm starting it in development mode. So it's gonna like wipe my blockchain each time. Okay. Which is kind of a weird concept for a blockchain to have it like constantly be wiped, but it's because I'm in development mode. And that's why every time I start this back up, like my block count is going, or block height is going back to like Genesis. Okay. That's on purpose. So yeah, so now if I go look at the extrinsics, before I had like this template module and I have my logistics module, but I still just have these two things here, you know, my do something and my cause error. Okay. So I need to like go in and make my changes for those. I'm going to look at like a couple of different, oh yeah, all these are broken now. So things probably we first want to think about is like, how do we model the data that we want to store? Okay. So we have like storages. We have a few different types of storage in Substrate. We have our storage value, which is what I have here, which stores like just a single value. Like think of it as just a regular variable. So that's probably not going to work for this because we're going to have, you know, multiple people who are going to be sending freight, you know, packages, whatever we want to call it, through our courier service. And we're going to need to track those different packages per person. Normally, when I think about this kind of thing, then I would think about, you know, a storage map. Okay, so let's look at like the different runtime storage options we have here. Okay, so here is the different ones. So we have our storage value, which is what's currently using. We have a storage map. And a storage map allows you to store a value under a key. Okay, and that's used a lot to store something against an account ID. Okay, so the key will be the account ID, and then value will be whatever you want to associate to that account. So that's probably a good starting place. But we probably want an account to be able to send multiple packages. Okay. So I'm thinking probably a storage double map. And a storage double map allows you to have 2 keys. You know, so we could have one key would be the account ID of the person who is sending the package. And the second key then would be the package ID. You know, so some value that we're assigning to the package, whether it be like, you know, U32, like some kind of like whatever it is, some unique value or unique to that user for that package. Okay, so I think we're going to definitely use a storage double map for it. Let's go back into here. So we're going to get rid of this like something. In fact, like that's such a bad name. We're also going to get rid of this getter as well. Not going to use those in this at all. I'm not going to talk about them because I think they're going away. Insider knowledge there, but I think they're going away. And we're going to rename this. So it's not going to be something. It's going to be package. So we got packages. They are going to be a storage double map. And then we have a bunch of stuff we're going to put in here. Now, the first argument is always going to be that prefix. Not going to change the prefix right now. We're going to keep it as an underscore. So the prefix is going to be our palette name of like logistics and our storage name of packages. Okay, I'm happy with that. Don't need to change it. And then we have a bunch of other things we need to put in, you know, so like what our keys are going to be, values, etc. Let's go look at the example of it. See me typing all out. Okay. So we have, here is our hasher, and here is what we're going to be hashing. So we're actually going to use the account ID as our first one. So let's pop this in here. Asher, this is a really important thing for us to talk about. Okay. Like super important. Whenever we're doing anything with keys and storages, I told you I could talk for hours about storages. I wasn't kidding. Okay. Um, whenever we're talking about like keys and storages, we have to think very carefully about how we're going to hash the value that we're going to use as the key. Okay. And the reason for that is because we don't want unbalanced trees. What do I mean? So let's go look this up. Okay, so we got a Patricia tree try. Patricia try. Okay, so here is a good diagram off it. We're gonna look at this. Okay. I love this Wikipedia one. It makes it really clear. Let's just open a new tab so we can get rid of all these other ones beside it. So this is how the keys are basically organized. Okay, we can see down the side here, we have a bunch of different keys. We have like Romain, we have Romanus, we have Romulus, Rubens, Ruber, Rubicon, Rubicondus. Okay, so they all share this starting letter of R. Yeah, but then it starts to diverge. Down the left-hand side, they all share the next two characters, OM. Okay, and down the right-hand side, they all share the next two characters of UB. With me so far? So we start at R, all the characters same for the first one. Then we have some that share OM, some that share UB. So we've now got these two branches going off, one for OM, one for UB. And then on the OM side, so going to the left, we have some that share this AN. Let's just AN. Not going to read out the rest of that word. We got some that share the AN. And then we have one like Romulus by itself that just has this UL US. Okay, so we can see how that works since we've got R to OM. These two words share this AN prefix. You know, so we start another node for them. Romulus, there's nothing that shares it. That just terminates there. And then under the AN, you know, we now have, okay, well, we have one is E, one is US, and they terminate here. Okay. And very similar going down the right-hand side. We have a bunch that share this UB prefix. Then we have two that share this E prefix, two that share this IC prefix, and so on and so forth. Now, when we think about our code and the fact that we're going to be using like account IDs, which are going to be provided by, or any data provided by the user, what would happen if a user sent and if we weren't hashing it? Okay, if we're just using whatever the user sent us, whatever value they sent us as our key without a hash. Well, if we look at this image, if they send us keys that all started with R, O, M, A, and you know, they can make us go down lots and lots and lots of hops by ensuring that as many value or many keys as possible shared the same like letters. Okay, so you're gonna have to keep hopping down all the time to get to the bottom, or shared like one letter each time. Sorry. So you can make it what's called an unbalanced trie or an unbalanced tree. And that is not a situation you want to get into, because then it becomes a lot more resource intensive to do that lookup. You know, you're gonna have to do a lot more hops. So if an attacker can force your tree to be unbalanced, then they can cause a denial of service against your chain, which is not something we want to happen. So Substrate has a bunch of different hashers that you can use. I can close this. Well, let's not close this. Just bring this up again. So Substrate has a bunch of different hashers that you can use. I think they're listed in here somewhere. Where is our hashing algorithms? Okay, cool. So we have this Blake 2-128. We have 2x64, and we have identity. Okay. There's also two other ones, which I will talk about, but you should not use. And that is Blake 2-128 and 2x64, but no concat on the end. Okay. But those are going away. Do not use those. Okay. And the reason for that is this concat means that it's transparent. what I mean by transparent hasher is that we concatenate together the input and the output. Okay, so that means that you're still going to get cryptographically secure hasher that has a uniformly random distribution of keys, but you can also see what the pre-image was, what the input was, and that is really handy for a bunch of different things that around like intervals and things that we can do internally in Substrate. Uses it a lot. Just trust me on this. Always use the concat versions. There's no reason not to, really. They are transparent. It gives you a lot of additional benefits. That's why we don't even list the non-concat versions anymore. Just use the concat versions. Okay. That said, we have two different hashers. We have the Blake 2 128 and we have a 2x64. As you can see, the Blake 2 is the only one that is marked as cryptographic. Okay. The 2x64 is not cryptographic. A attacker could force a unbalanced tree try using it, but it is faster. Okay, so I personally very rarely would ever use this. If I'm going to be hashing something, I'm always going to want a cryptographic hash. So I just use by default to the Blake 2 128. Okay. Now the identity hash, as you can see, is not cryptographic. An identity hash will just take the input and make it the output. Does not hash it at all. The only time you should use an identity hash is if you've already hashed the value yourself. Okay, so you already know that the value is a hash, a Blake 2 128 hash. Okay, that is the only time you should really use the identity hasher, because there's no reason for you to rehash something. Okay, if you have hashed it yourself already and you want to use that hash as a key somewhere else, then you can use identity. Do not trust, however, that if you ask the user for a cryptographically secure hash, that is what they are providing you, and then use identity, because you can't trust user input. So unless you have to have hashed it yourself somewhere else in the business logic of your code, that's the only time where you can really use the identity hash for like keys. Okay. Any other time, you're probably going to use the Blake 2 128. If for whatever reason you are sure that you do not need a cryptographically, or you're sure that the user cannot force, or cannot provide pre-images, is going to force you to have an unbalanced try, then you can use a 2x64. Situations where that might be reasonable to use is the value that you're hashing to use as a key is not coming from the user. Okay, it's the block height. Okay, that's fine. If you want to use the 2x64 on the block height to generate a hash, don't know why you would, but if you want to do that, fine. It's going to, the block height is not coming from the user. It would be slightly faster to use the 2x than it would be to use the Blake 2. In that situation, yeah, knock yourself out. Don't need to have a cryptographically secure hashing function. You're not going to get an unbalanced try. There's no real attack vector there. You can use a 2x64. But any other situation, or anytime you're unsure of which one you should use, just use Blake 2 128. Hey, hi Jafar. Hello to you as well. Have I hammered this point home enough about the hashers? Like, have I really labored this point as much as I should, or should we keep going? Everybody gets it. Blake 128 or Blake 2 128. Awesome. Okay, thank you. So we're gonna use Blake 2 128 concat here. The first key that we're going to use in our storage level map is going to be the account ID of the person who is creating the who's wants to ship something. They're creating the delivery. Go away. And the next thing that we're going to put in here is going to be an ID for that delivery. Should we ask the user to supply the ID? Should we supply the ID? Should we generate an ID? this is questions that we probably could ask if this was a real logistics pallet. I'm going to say that we are going to. What should we do? Should we just generate it for them? Like the block height plus the. Yeah, no, we'll just ask them for an ID. You know, let's just do it that way. So we're gonna do a black. I was kind of wondering, like, okay, if we did, you know, the count of how many deliveries they have plus the current block height, you know, add those two together, and then hash that, we could probably get away with doing the 2x64. And should we do the 2x64 just as an example of how to use it? Should we do that? No. You'll get the hashing thing. I don't need to go over it anymore. We're just gonna do blank 128 concat, and we're gonna say that the user is gonna supply a U32 as the ID, and we're gonna leave it there. Looking for a swap example with ink in substrate. No any. Not off the top of my head, to be honest, Jafar. The best place to ask that, if I'm being 100% honest, is ink runs a regular Twitter space. I think weekly. Not sure if somebody can like confirm that for me. I think it's weekly. You know what? I probably have the calendar here. Let me just double check this for you. I think it's like a weekly thing on their page. If it's not, it might be monthly. Let me just see if I can find a content calendar. Do I have it? Do I have it in here somewhere? No, not easily look up, unfortunately. It might be a monthly thing then. Anyways, yeah, the best place to ask it is on their Twitter space. I'm not sure when the next one is going to be. I will put their Twitter in here. So Jafar, if you go follow Inklang on Twitter there, you should notify you when our next Twitter space is coming up. And that is the best place to ask that question, if I'm being 100% honest. They will know much better than I would. Like what example to give you. So yeah, I would definitely subscribe to their Twitter and then just keep an eye out for the next Twitter space and ask there. And like the actual people on the Twitter space are like the Ink core devs. They'll be able to answer that question easily for you. But just asking like, how about incrementing nonce? Yeah, exactly. That's kind of what I was looking at with using the count of the number of deliveries they currently have is essentially that, you know, really, without having to like kind of, you know, use any randomness or any other yucky stuff like that. It should be enough to have just like the block height and the count of current. Although would that be enough actually? Like if somebody manages to submit 2 deliveries within the same block is being offered, you know, within like 1 block, so counting 2 extrinsics, the actual count. I'm trying to think now, storage wise, would that be updated? Would that or don't need to would there be a clash in IDs? I don't think there would be, actually. I think once the first extrinsic completed, that it would update that the transaction layer, but like the other storage layer above it, and that would still be able to update the count. So I think it would be okay. Yeah, even if multiple calls are made to the like start delivery extrinsic within the same block being offered, that count would probably still be accurate. And it would still give us a unique like nonce that we could use along with the block height to give us an ID for it. But that sounds like way too much work for us to do. Instead, we'll just ask it, the user, to provide us with a unique ID. If they don't provide us a unique ID, well, that's their fault. We're still going to take the fee anyway for the call. Yes, CoX1D is saying it still works. They get executed in sequence. Yeah, I knew they get executed in sequence. I'm just like, I was trying to remember the different storage layers, because it's the very top layer in storages, or bottom layer. Bottom is going to be the database itself, and that's has the highest latency to read and write from. So whenever you're like offering a block, then the layer above that is, I can't remember what the term for it is. What is the term for that layer? I know we've got the transaction layer, which is like per extrinsic, and there's another layer which is like a caching layer for that block that's being offered, but that's not what it's called. There is a term for it, and it's escaping me right now. But it's essentially to stop us having to constantly be writing from the DB, which is slow. The extrinsics are going to read and write from, well, it's going to request it from this layer. If that layer doesn't have it, then it might pull it out of the DB. And each extrinsic is going to have its own transaction layer, which is really cool, because it means, for example, there is an error in an extrinsic. You've done a bunch of like modifications to storage values, and then towards the end of your call, or towards the end of your extrinsic, you figure out that, oh crap, we can't complete this for whatever reason. There's some preconditions not being met or something else, and your extrinsic returns an error. Then all of those modifications that you made to those storage values just get thrown away. Like, you don't need to worry about like rollbacks or like ACID transactions or any of. I used to work at MongoDB, so this is like something that, it's my heart. You need to worry about any of that kind of stuff. It's like, oh, I can be assured that if I return an error from my extrinsic, that any modifications I've made to any storage values are just going to be ignored. It also means as well, which is really kind of cool too, if I make a bunch of modifications to a particular value, so I read a value, and then like I add something to it, and then I go, oh, actually now I want to send this value to this other account, or I want that account to like transfer it here, and I do a bunch of different stuff, moving a value around. None of that is saved either, all of the intermediary steps, because we don't need to know that. Instead, all it's just going to save is like the state change. So again, like, it really saves an awful lot of interactions with the bottom layer, with the DB, which is the slowest part of it. It's going to have the highest kind of latency. So doing it all in this transaction layer and extrinsic is like super smart. Once extrinsic's finished, then it's going to put it into that other layer, which name I still cannot remember. And then finally, once the block is offered, then that's going to be saved into DB. So what CoX1D is talking about here is, the extrinsic get executed in sequence, and once each one's complete, it's going to update that intermediary layer. I'm going to look at the name of this layer up as soon as this stream finishes, I promise you. It's going to like write it to that layer, but then my next extrinsic is going to, if it interacts with that same storage, is going to read it from that intermediary layer as well. So I will be able to see the changes that are being made, so I don't need to like wait until the block has been finalized to know that, all these extrinsics that executed in order, it'll like get the correct values for each one. Hope I explained that. Storage overlay. Thank you. Word just would not come. Like, I don't know why. Essentially an intermediary cache, but I knew there was a term for it, and I knew if people wanted to go like search the documentation for this later on, I didn't want to be given them incorrect terminology. So I wanted the actual like word. So yeah, if you're going to look up in Substrate docs later, it's the storage overlay is what I'm talking about, but it is essentially an intermediary cache. Cool. Folks are asking in the chat how they can reach out. They have a few questions. If you've got questions about what we are talking about today, ask them in chat. I will happily address them for you. If it's questions that are not related to what we're talking about now, depends, I guess, is the best answer there. If it's something that you think we here at Developer Relations at Parity can help with, you can email us. It's devrel@parity.io. Send us a message there. We have our matrix. It's got like some public channels we can go talk to different teams on. We have Twitter. I mean, the different teams also have presences there as well. So we have, the Inklang Twitter. We have one for Substrate. We've got Polkadot. We've got Parity. A lot of the teams as well do like Twitter Spaces and things you can ask. There's a lot of stuff going on. So yeah, really, Web3 education investment depends what your question is. So if it's something about what we are doing on stream, I'll happily answer it now. If it's something, related to something else, then probably your best bet is to look at the community section. Let me see if I can pull that up for you. Where is... Be like Polkadot. Whoa. Type. Oh. I think in here there is a community maybe or something similar. Here we go. Join the community. Everything you could ever need in there, buddy. So you have, as I said, we've got our Twitter, we've got Discord, we have Element Chat, we've got mailing lists, all different places you can reach out. And I will drop that link in chat for you just there. So, yeah, plenty of places to get in touch with us. Also, as I said, there is different Twitters for different teams. Inklang has their own Twitter, as is Substrate, Substrate_IO, Ink_Lang. So if you have something particular to those teams, go follow them on Twitter. They hold regular spaces. Send them at whatever it is you need to do. Okay, so we are coming up kind of on time. I'm going to finish writing this one storage, and then we're going to be done. So I've got my current ID. We're going to ask the user to supply us with an ID for now. There's some great ideas in the chat about like how we could generate this ID for them, but I'm going to be lazy. And then we're going to have the actual value of what we're going to store, which we're probably going to want to write like, a struct for this, and we can store this in. So I'm just going to call this package right now. It's not going to be defined, but we're going to create, some kind of data model for this, because a package is going to have like a bunch of different things on it, so it's going to have, a record of who received it, where they received it at, what block height was received at, because we can kind of finagle the time from that. We'll want to have, where is it going to, what's the destination for it. One thing we're not going to have, though, is a list of all the places it was received. We talked. Fine. Let's bring this back to like our previous value, so we can go have a look at this. Hopefully, this still builds. What's running? Cargo check. Oh, waiting for foul log. Unrest analyzer, stop. There we go. Yeah, okay, cool. So let's just build this. We're only ever going to store the most current state of our package. Okay, we're not going to store like a long list of everywhere the package has been. Yes, we need to have that information. You think of like if you've ever got something shipped by like FedEx or UPS or USPS or any of the other ones, you can go to like your order page and it'll show you the delivery history, that, hey, it left from this depot and was checked in here, and then it went to this other place and then it's checked in here, and so on and so forth. So having that history is really important, but we're not going to store that history in our storage because it's a blockchain. It's an immutable ledger that exists. We don't need to keep adding to it each time. what we can do is instead is replay any of our state changes and look to see what the state of our storage was at any particular block height. It'll become clear once this builds, and I can go show you with our something storage and how we can change the value on that as to what I'm actually talking about here. Because the reason we don't want to just keep like, we don't want to create like a vector and just keep adding in, each time it's been checked in, because that could grow unbounded. We don't know what size that's going to be, and like everything in kind of block space, storage has a cost. Execution time has a cost. All these things have a cost. We want to try and keep those fees as low as possible. So we don't want to be willy-nilly adding things into a storage. We want to be very precise about our storages and what we're storing and why we're storing it. And there is no reason for us to keep a long list within a storage whenever the chain is keeping that record for us itself. So, okay, we have our generate running. This is going to be like last thing I do today, and then we're going to call it. So we have our extrinsics here. Let's go look at our logistics module. It's got this do something. So we're going to store a value of 10, submit our transaction, sign and submit. Wait for our block to be offered. Okay, let's change this value now to 20. Submit transaction, sign, submit. Change our value to 100. Change our value to 500. Okay, so if we go look at our Explorer, we can see here, that our something now is 500. Okay, and if we go look at our chain state, and let's go look at our something, we can see 500. Okay, that's what we expect to see, because that's the last value that we stored. So that is the current state of that storage. This should give you a clue as to what we're going to do. Okay, so we have this block hash to query at. So let's go look at this, and we've got like a storage here. And what do we do in this one? We change it to 20. Okay, so let's get the hash for this. And let's go back into our chain state. And we're going to query our something at this hash, 20. Okay, so even though we're overwriting it every time, it's a blockchain. The whole point of the blockchain is it's a immutable ledger. So even though we're overwriting it, we still have a record of the state changes. So we can still go back to any point in the history of that storage and see what the value was. Okay, so hopefully this is starting to make sense now. It's like, okay, so we don't need to store a long list in that storage of like every place this package has been. We just need to update that storage item each time. And then we can just replay the state changes and see at any point in its history what the state of that storage was at that time. And Humus is asking, and we can make that query all the way back to the first state of that value on the chain, right? Yeah, we go all the way back to Genesis. Okay, like I'm just randomly grabbing a hash there to look at the what the value was at that particular point in time. But yeah, you can do it right back to Genesis. That's, well, yeah, for a chain that's not forked. Yeah, you can get right back to Genesis. This is right back to Genesis. Okay, so we can just look at the history of that. That's the whole point of this. It's immutable, can't be changed, etc., etc. But we are pretty much out of time for today. Hopefully, folks have enjoyed this first stream. We're going to be, as I said, doing these on a really frequent basis. I'm going to try and do it every Thursday, at least to start off with. Conference commitments permitting and things like that. But yeah, I would also love to, like, any feedback people have, questions you have, things, directions you'd like to see this go. Like, is there anything in particular you want me to add into the module or talk about, or an area frame that you're like, yeah, let's go explore that. I want to learn more about it. Because if not, I'm going to talk about storages like constantly. That's storage isn't hashing, and why you should always use a cryptographically secure hash. Like, I'm just gonna just constantly rant about those otherwise. So please do put in, like, you can at me or DM me on Twitter. I'm R Ambassador. I'm R Ambassador pretty much everywhere. Or on the GitHub link that I put in, put an issue on there, but something you want to talk about, whatever way, I'll see it, and then we'll try and incorporate it into future streams. But yeah, thank you so much, everybody, for joining me today. This has been a lot of fun. I forgot how much fun it is to do live coding and to chat with people on streams, so I appreciate that a lot. And I will see you next Thursday. Enjoy the rest of your day, folks. Bye.